Hello everyone, my name is Aman. I am MTS intern at VMware. So today we are going to solve problem of the day at Geeksforgeeks. So it's 11 March. So let's start with the problem. So today's problem is that height using parent array. So given a parent array of binary tree means a tree which can have maximum 2 nodes and minimum 0. So let's give some brief about binary tree, then we can proceed with the problem later. So binary trees that with the name binary itself means that two things are there. So there is a node which can have at least 0, 1 or max 2 nodes. So this is basically what binary tree is. So a tree whose node can have maximum 2 and minimum 0 nodes. So that is a binary tree. So yeah, so element index of at index I in that array represents the parent of its node. Okay, so element at index I. So what's ever be the value at index I is the parent of that particular index, right? So suppose let's read out the complete problem, then we can explain step by step. So represent the parent of that, that is a of arr of I is equals to parent of I. Find the height of the binary tree, and there will be a node in the array where arr of I is -1. Okay, which means this node is the root of the binary tree. Okay, yeah. So suppose n is the number of nodes. This is the array which they are giving. So -1 means that it's the topmost node in the tree, or what we can say that first node in the tree. So -1. So 0 means 0, that is index 1 is a child of 0 node. So that is what they mentioned, that array of I means that index is equals to parent of I. So I index value and array of I the value of that particular index, that is 0. So 0 is the parent of index 1 means node 1. Again 0 is the index of node 2, so that is 1 2. So then 0 1 2 3. So 3's parent is 1. Okay, 4's parent is also 1. Okay, so 3's so 4 5. So 5's parent is 3. Okay, makes sense. And that index 6 whose parent is 5. So okay, so in this way they have created a tree. So this is what parent in array is called. Okay, so each index parent values mentioned. So you do not need to read input print. Okay, so that's the details about the function what they have given. So expected time complexity is that n of square, so quadratic. Okay, so expected auxiliary space, so we don't have to use any extra space other than the constant a b variables. Okay, so okay, so let's draw any so suppose this array. So they want the height of the tree, right? So the height of this tree is that 1, level 1, level 2, level 3, level 4, level 5. So 5 is the height of the tree. So if we start thinking from this side, that okay, so we can run so n square means we have to run 2 loops, right? So 2 loop on this particular array. Okay, so one way what we can say that if we found the chain or the longest branches which are connected together, like 0 connected 1, connected 3, connected 5, connected 6. So if we observe this pattern in this array, so 0 uh, uh, which is connected to 1, then 1 is connected to 3 and 4, then 3 is connected to 5, and 5 is connected to 6. Okay, so this is the chain. So if we if anyone is thinking that we have to start with the initial first index, then I don't know that is there is chance to solve this problem if we start with the initial. So we can't go with from this index to the last leaf nodes. Okay, if in case we can go, then time complexity will be greater than n square. So yeah, there is a way that is DFS, which is a algorithm, depth first search, used in graphs. So we can apply that thing, but in that case also the complexity is not n square. It might be greater than that, but not n square for sure. So we can discuss that approach too. I can give some overview, like we can start with each node, or we can start with the only parent node. Then we can go all its connected node, like 0 sorry 0 okay, so there one time we will go from here, then in the next one we will go from here, then we are going here from 1. So 1 is connected to two nodes, like one is connected to two nodes at 3 and 4. So one time we will go for 3, then will go for 4. In this way we can go, but that is not the efficient way. No, it will take so much of time. We will not fulfilling this particular time complexity, right? So instead, from the starting we can start from the end, right? So this is index 7, sorry 6, if we start with 0. So this is index 6, so that is node 6 also. Index is similar to the node number. So 6, which is connected to 5. Okay, so 5 is just one right left, sorry. So 5, so we go to 5. Okay, so 1, we have okay, so this is 1. Currently the height of the tree, just if we say this, we will count this, so it's 1. Then we are moving to 5, node 5, index that is 5. So we are moving to this, so 1 increase to 2, then we are now at 5. Then we are moving to 3, so 0 1 2 3. So here sorry, here we are 1, so here is 1, then 2, then 3. So now the value is 3. Then again we are at 0 1 2 3. So 1 is moving to this is an index 3 whose parent is 1, so that is this value. So at 6 we have height 1, then we increase by 1, then 5, sorry 2, then 3, then 4, and at last we've reached to -1. That is our indicator that okay, we have reached to the left side end of the array. So that is 1. So now the value have changed, right? So 1 2 3 4 5 we can do that. Similarly, what we can do is that we can start with the each index from the starting from the left. Right, sorry. Once we had started from here, we will update. Okay, so let's draw a tree, right? Okay, so I am just simulating the same tree. Okay, so okay, so this is the tree, right? So we have started from the last index 6. So here the value was, height of the tree was 1. Let up to our we can start from here also, that count will be same, right? If we are counting from the upward side or downward side, the height will be same, right? So here 6, we are at index 6 or node 6, the height is 1. 6 is pointing out that its parent is 5. Okay, so that is 3, whose parent is 3. So 5, if we are moving to 5, then the height of the tree will increase to 2. Then 5 is pointing out that its parent is 3. So here, so its parent is 3. So let's write the value, sorry 0 2, sorry, 1. Okay, so 1, again 0, 1, 2, 3, 4, 6. Okay, so 5's parent is 6, we can know from the parent array. So if we are moving to 3, we are increasing the height 3. So 3's parent is 1, so that is 0. So in whose parent is 0, 1. So 4, and 1 parent is 0, then 5. So this is one iteration. Maybe in this question we got the answer only one iteration only, because this is the longest tree. But in other questions, how things will occur is that after this particular last index we will move to this. Okay, so it's node 3, node 4, and whose parent is 3. So node whose parent is, sorry, it's not 4, it's not 5, whose parent is 3. So this is the one. So whose parent is 3. So we will update the height. So here we are starting from here, so height is 1, then moving to 3, so then 2, then 1, then again 0, 4, right? So we have covered 1, 2 index, then third. Similarly, in this way we are moving from the last, right? So whatsoever is the height or maximum height, we will get at the end of this question. So let's go to implementation part. So I have already solved this question. So suppose if there is no node, so there is the height of the tree is 0, right? No node height 0. So let's start with create a variable maximum height. So if there is node, so then in starting we can assume that at least the height of the tree is 1. So if there is minimum 1 node, so height is 1, right? Then we are starting from the last index, going to the second second element, till the second element in the array. So then we are creating a current height, right? So what we are updating, right, here 1, 2, 3, 4, this is the current height. So we are initiating with 1, because at least there is a 1 node in the end, or if there is no node in between, so that is also the 1 node. So 1 node is here. Current index means that is the parent index we will store. Okay, so its parent is this, then we move to that particular index. Then okay, so whose parent is that at that particular index, then we will move to that. In this way we will move until we reach to the -1 value. So I mean that topmost element of the tree. So while array of current index is not equal to -1, that is we haven't reached the top of the tree, then current index will update it with the parent particular of that particular index, and we are increasing the height. And after that particular iteration get over, we are running max height function, and we are updating max function, and we are updating the max height. So after this particular function will completed, then we loop completed, then we are returning the max height. So let's see what's the time complexity of that particular we have. Okay, so we have passed all the test cases, and total time is 0.2, so it's not that much out of 1.4. So yeah, this is the question which is regarding the tree, and yeah, many companies ask this kind of question. The thing is that if you are solving a trees question, if there are question related to nodes, so that is the easy one. But sometimes question come with the array itself, like they have given just array of tree, they haven't created any node, they haven't give any data structure which creating node and they are connected, they have just given the array. In BST, that is binary search tree and binary tree, questions are normal nowadays, and they are some trickier one, like if the trees find the height of the tree, they have created a tree and finding height there is easier one than then the questions like these. Okay, so yeah, thanks for watching this till now.